Hello friends, my name is Rahul Joshi and today we are going to see about TCP Congestion Control. So first, what is TCP? TCP stands for Transmission Control Protocol. TCP is a protocol which creates and maintains the connection between hosts. TCP used for reliable errorless transmission of data packets. Generally, TCP use sliding window protocol for packet transmission. So now, what is sliding window protocol? It's a protocol which is used for transmitting number of packets at a time. So now, we will see what is congestion. In a, in a real time, congestion means traffic. What will happen if number of vehicles come together on a single road? It will be very difficult for them. So we call it as a traffic. Similarly, in networking term, it's a state of link or a node which carries too much data packet which degrades the performance of network. That is, if number of packets traveling come at a single link or a point which exceeds its capacity, then the congestion will occur. So now we can look at this graph. That is, if congestion doesn't occur, then the packet delivered gradually increases. But when the congestion occur, they decreases at the same time. At a point, they get decreased. So we need to control the congestion in order to conserve the speed or the packet delivery in the network. The congestion occurs when the window size exceeds network or receiver's capacity. The window size represent the number of packets sent at a time, and if it exceeds the capacity of network or a capacity of receiver, then the congestion will occur and the packets will be lost. The amount of data to be sent is controlled by congestion window. The congestion window is a window which which present at the sender side and controls the data packets, number of data packets to be sent. And at receiver side, there is a receiver window which receives the data from the network. The congestion window starts from MSS, that is maximum segment size, and grows up to the receiver window until the congestion occur. If the congestion occur before it reach the receiver window, then we will see what to do. Okay, so now we will move to the TCP congestion control. TCP TCP controls the congestion by adjusting the window size. If there is more congestion, then it decreases the window size in order to reduce the packet to be sent, and hence the congestion is controlled, or the load on the network is decreased. So TCP used AIMD mechanism to control congestion. So now we will see what is AIMD mechanism. AIMD stands for additive increase multiplicative decrease. So the congestion window size increase additively. That is the increment. Here we have given the formula for the increment equal to MSS, that is maximum segment size. So it is this maximum segment size is the size of a segment which maximum size of segment which doesn't need to fragment. It doesn't need to fragment. So MSS into the current congestion window is the increment, and if the new congestion window size is equal to the previous congestion window size and plus increment, the congestion window is decreased multiplicatively. As the name suggests, additive increase multiplicative decrease. Okay, so here the formula is given. The congestion window, new congestion window size equal to congestion window divided by some constant, or we can also reset it to 0 in some cases. Now here the formula is given: threshold equal to congestion window size divided by 2. The what is threshold? Threshold is a quantity threshold is a quantity which is which represents that the window size, our window size, is reached up to the half of the maximum size of congestion window. So we can further we can control the window size or the growth of the window size in order to prevent or it is a precaution for a congestion. So now we will look at example. Suppose TCP maximum suppose for TCP maximum congestion window size is set to be 24 kb. That is, maximum congestion window size is 24 kb and timeout occurs. Calculate the window size of 7th transmission, and here the MSS, that is maximum segment size, is given as 1 kb. So here we draw a graph with x-axis as a time, and on y-axis there is a congestion window size. So now for a first transmission, the congestion window size is 1, that is MSS. Since MSS is 1, the congestion window size is 1. So one packet is transmitted, then it is increases. How we will see how the this graph works. So according to the formula, increment equal to MSS into congestion window size. So for after first transmission, the congestion window size is 1 and MSS is 1. So increment is 1 into 1, that is 1. So the next now the congestion window size has become the previous congestion window size, that is 1 plus increment 1, so 2. Here we can see, here it is 2, and then now the congestion window size after the second transmission, congestion window size is 2, and now the new we have to calculate new congestion size. So it is the increment is MSS, that is 1 into congestion window size, that is 2. So increment is 2 and the previous congestion window size is 2. So now new congestion window size is 2 plus 2, that is 4. Here we can see it. Next, similarly for next transmission, the increment is MSS into previous congestion window size, that is 1 into 4, and the new MSS becomes 4 plus 4, that is 8. Now for the next, here we can see slight different, it should be 16, we will see it. So now for increment, the next increment is of 1 into congestion window size 8, that is 8, that 8 plus 8, the new congestion window size should be 16. But now as we saw that threshold, which is indicates that we have reached up to the half of the maximum congestion window size. It is here the maximum congestion window size is 24 kb, and here we calculate the next congestion window size 16, but which exceeds the threshold, that is 12. So here we cancel out the calculated window size and set it to threshold, that is 12. And now we're going to take some precaution that it should not the congestion should not occur. Okay, so we will increment by MSS. The window size will not be incremented as we have seen that increment factor, but it will be now incremented by the factor MSS. So here we can see it is after 12 it is incremented by 13, and now it is 13, 14, 15 and so on. So now we have drawn the graph and we have to calculate the 7th transmission. So we'll take a 7th transmission, that is 1, 2, 3, 4. This is the 7th transmission, 14th. So at the 7th transmission, the current window size is about 14. Okay, so we have solved this example, but in this example there is no congestion. But what it will do, what TCP congestion control will do if the congestion occurs. Now see, we will take a same example. We have drawn the same graph what we have drawn before up to this 7th transmission, and now we will consider that at 7th transmission the congestion occurs. Then now this immediately the congestion window size will be decreased. It might be decreased as we have seen the formula as we have seen the formula, that is congestion window size divided by some factor or C, or we can reset it to 0. So we will continue with resetting it to 0. So now here as we can see, it is the congestion window size is now 0, so reset to 0, and now again it will it will be recalculated as before. So at the next transmission the congestion will be set to congestion window size will be set to MSS, that is 1, and so on. What we have seen, that 2, 3, 4, and now here we can see the difference, that is here it is 8 and here it is 7. That's why, because when the congestion occur, the new threshold value is set as half of the previous congestion window size. Previous maximum congestion window size. Here it is a maximum congestion window size is 14. So the new threshold is set to 14 divided by 2, that is 7. So here according to our formula, increment equal to MSS into congestion window size, the value should be 8, but it exceeds the threshold value, so we set to 7. So after the 7, we continue to increment by MSS, that is here MSS is 1, so we will see the next transmission as 8, 9 and so on. So that's it. Thank you. If you like this video, please subscribe our channel, and you can see others video too. Thank you very much.